Okay, so let's continue again, okay, with our module 5 application layer. Okay, so next is, okay, module 5. Module 5, not module 5, it's module 15. Okay, so for application layer. So previously we talked about the transport layer, which is one layer beneath the application layer. So the top one, the highest one, is what we call as the application layer. So okay, so application. Okay, so in this case, they have in application layer they have three types of terms that you need to remember, which is application, presentation, and session. Okay, even though it is called in a TCP/IP model, we call application layer. Okay, basically inside it we have a lot of things, okay, which is in the OSI. Okay, OSI model, we call it application, presentation, and session layers. Okay, so the application layer provides the interface between the applications used to communicate and the underlying network over which messages are transmitted. So some of the most widely known application layer protocol, they include HTTP, FTP, TFTP, IMAP, and DNS. So domain name system, which is DNS, Hypertext Transfer Protocol, HTTP, Simple Mail Transfer Protocol, SMTP, Post Office Protocol, POP, Dynamic Host Configuration Protocol, DHCP, FTP, and then you have IMAP as well. So all of them is at the top. So this one is where your application, okay, they provide the interface between this application layer. They provide the interface between all those protocols above, okay, DNS and everything, okay, to communicate and the underlying network over which messages are transmitted. So for presentation and session layer, okay, here, okay, previously we talked about the application, right? So for presentation, here is where they have three primary functions: formatting or presenting data at the source device into a compatible format for receipt by the destination device. And then they are tasked to compressing data in a way that can be decompressed by the destination device, encrypting data for transmission, and decrypting data upon receipt. Okay, so here you look at in this figure here. Okay, you guys can see, right, my screen. You can see, yeah. Okay, so here you see that here you look at into Matroska video MKV. Okay, here MPG, MOV, GIF, JPEG, PNG. What do you think presentation represent here? You can see all this. What are those? Anybody know? Anybody know? What are these? In a simple word, what are they?
Format.
Format for what?
Niche.
Media format.
Media format. So they are mostly images and videos, right? So this is for presentation, images and videos. They are being processed in the presentation layer. Okay. So the session layer functions create maintain dialogues between source and destination application. It handles the exchange of information to initiate dialogues, keep them active, and to restart session that are disrupted or idle for a long time. So this is to avoid any problems in when you want to play images or anything. Okay, so they tend to make sure that all those presentation can be occurred as much as good as what it intended to be. So in the TCP/IP application layer protocol, the TCP/IP protocol specify the format and control information necessary for many common internet communication functions. So the application layer protocol, they are used by both the source and destination devices during a communication session. For the communication to be successful, the application layer protocol that are implemented on the destination host must be compatible. So in case they are not compatible, means that maybe they are different in terms of configuration of OS and everything. Okay, they cannot communicate for those services. So like for example here, domain name system for DNS, okay, TCP UDP client 53, translate domain names such as cisco.com into IP addresses. Okay, here DHCP client 68 server 67, assign IP addresses to be reused. Okay, and then you have HTTP, TCP 8080 port 8080. Here, a set of rules for exchanging text, graphic, image, sound, video, and other multimedia files on the World Wide Web. So, and then we have peer-to-peer. Okay, that one is application layer. And then we have peer-to-peer. Okay, peer-to-peer is a client-server model. Okay, a client and server processes are considered to be in the application layer. In the client-server model, the device requesting the information is called a client, and the device responding to the request is called a server. And application layer protocols describe the format for the request and response between client and server. So here in this case, you have a server and then you have a client. You are going to download them from the server. So this one involved in the application layer. And next we have peer-to-peer networks. Okay, in this case you have two PC sharing a printer. Okay, in a peer-to-peer network, two or more computers are connected via a network and can share resources such as printers and files without having a dedicated server. Every connected end device, okay, can function as both a server and a client. One computer might assume the role of a server for one transaction while simultaneously serving as a client for another. The roles of client and server are set on a per request basis. So as you can see here, the printer is connected to peer 2 means that when a peer 1 wants to request to print, peer 2 has to become a server. Okay, when peer 2 want to print, okay, peer 2 will become a client, and this one will be a server. So this is a case of the peer-to-peer networks. A peer-to-peer application allow a device to act as both a client and a server within the same communication. Okay, so in case of peer-to-peer, before this, okay, 10 years ago, uh, before we have Steam, before we have Netflix and everything, okay, people used to share games and then videos or movies through what we call torrent. So torrent acts as peer-to-peer networks. So when you want to download something, somebody else become a server and you become a client, and then they will rotate. Somebody wants to download, you become a server, they become a client. So this is one way peer-to-peer application has been used. So some peer-to-peer application use a hybrid system where each peer accesses an index server to get the location of a resource stored on another peer. Okay. So common peer-to-peer network. Okay. So for application, each computer in the network that is running the application can access client and server. Okay, common here is BitTorrent, okay, Direct Connect, eDonkey, FreeNet. So most of these they are illegal software distribution services lah. Before this, I think you guys might not know about this. We started with LimeWire before during my generation at the same age as yours. So we download animes, we download movies, we download games sometimes, okay, uh, through the peer-to-peer platform. Lah. People share them, we download them, and now it becomes illegal. So that's why you have services like Steam, you have services like Netflix, so that you can watch all of those online, legally paid, so that people who are uh, who develop those contents, okay, those product can obtain some money out of your purchase. So this is one of the things that we got previously lah, 10 up until 10 to 15 years ago. Next, we have web and email protocols. Okay, so web email protocols, usually for web, we have the HTTP protocol. Okay, so when a web address or uniform resource locator URL, in case you don't know what URL mean, uniform resource locator is typed into a web browser, the web browser establishes a connection to the web service. The web service is running on the server that is using the HTTP protocol. So how to better understand how the web browser and web server interact is mean how a web page is opened in a browser. Okay, so look at when the browser, when you want to open a web page, you have to enter the URL HTTP, put in the server name, which is in this case cisco.com, and then you have index.html is the specific file name requested at the server, which is might be the front page of the web page itself. So and then so when you are requesting, okay, first, okay, send step one, you put in the address and everything. Step 2, the browser then check with a name server to convert the cisco.com into a numeric IP address, which it used to connect to the server. The client initiates an HTTP request to a server by sending a GET request to the server and asks for the index.html file. You are requesting the page from the server. And in step 3, in response to the request, server sends the HTML code for this web page to this browser so that the browser can display the page of what you requested. And next, the browser will deciphers the HTML code and format the page for the browser window. And then you can see the page inside your browser. So it's just a simple process involving the HTTP protocol. And then we have two type of HTTP protocol. The first one we have HTTP, and then we have HTTPS. Okay, HTTPS. Sorry. So HTTP is a request response protocol that specify the message types used for the communication. So there are three common message types, which is GET, POST, and PUT. So GET, this is client request for data. A client sends the GET message to the web server to request HTML pages. And then you have POST, this uploads data files to the web server, such as form data or anything you put inside the web pages. And PUT, which is this uploads resources or content to the web server, such as an image. Okay, so here you upload the image into the web server, you will be under PUT. So here you can see that for HTTP server from the client requests URL, HTTP request. Okay, here in this case, the file being requested back to the client. So HTTP is not a secure protocol. In case for secure communication sent across the internet, usually we have HTTPS. Most services, like for example online banking, everything, they have this HTTPS available in their web pages already. Next, for email protocol. Okay, email protocol, they have two types of protocol, which is SMTP and POP and IMAP. So SMTP is simple mail transfer protocol, and then you have post office protocol, okay, used for clients to receive mail. And then SMTP for sending, okay, POP and IMAP is for receiving. So they store the email, okay, and then you can retrieve it directly from the server. So in case you are sending, in this case, you're sending in the internet, you go towards SMTP, and SMTP will uh, take the email from the server and send it towards the receiver mail server, which is under IMAP and POP3. and here it will receive and open by the recipient. Okay, for SMTP, POP, and IMAP. Okay, so here a person is sending email. Okay, will send SMTP towards it SMTP server. Okay, and then from here, is the recipient in my list of recipient? No. Forward the email to another server, and then here from this server towards this server, he will also send it in SMTP format. Okay, and when it received, when it is received by the server and the user is in the recipient server, okay, and then the recipient will be able to access to the email sent by the sender. So this is how exactly how your email works. It doesn't necessarily mean email, it can be your WhatsApp and everything, same thing, same process involved. So once in the when the recipient wants to access, okay, the server will start a POP3 services by passively listening to the TCP port 110 for client connection request. Okay, when a client want to make use of the service, it will request for the server. Okay, the connection will be established. The client can exchange commands and responses. Okay, until the connection is closed or aborted. So IMAP also the same thing like a POP3. Okay, instead. So this is another one. Unlike POP3, when a user connects to the IMAP server, copies of the message are downloaded to the client application. The original message are kept in the server until manually deleted. But in case the user decides to delete message, the server will synchronize that action and deletes the message from the server. Okay, next for application layer, we also have the IP addressing services, especially when you want to request for web pages. Okay, web pages, usually when you request for web pages, you type in the domain name. Okay, so the domain names were created to convert the numeric IP address into a simple recognizable name. Fully qualified domain names, okay, FQDN, such as here Cisco.com, they are much easier for people to remember than the IP address. Okay, it's hard for us to remember IP address like we now, even now, we didn't remember uh, our friend's phone address. Okay, so here the DNS protocol defines an automated service that matches resource name with the required numeric network address. It includes the format for queries, responses, and data. So here, when a DNS server, the client requests, okay, a DNS query, he put in this cisco.com. DNS server will provide with the IP address, and from the IP address, will send towards the intended server. So for DNS message format, okay, there are several message format here. So they record, the server stores different types of resource records that are used to resolve names. Okay, the records contain name, address, and type of record. So in type of record here is A, an end device IPv4 address, NS authentication authoritative name server, and triple A of quad A, sorry, not triple A, quad A, an end device IPv6 address, and MX is a mail exchange record. When a client make a query, the server DNS process first looks at its own record to resolve the name. If it is unable to resolve the name by using the store record, it contacts other server to resolve the name. After a match is found and returned to the original requesting server, the server temporarily stores the numbered address in the event that the same name is requested again. Okay, so that's why when you want to request new website that you aren't often open, okay, you rarely open or you never open before, it takes some times to load because they are requesting the IP address from the DNS server. So DNS uses the same message format between the server consisting of a question answer authority and additional information for all types of client queries and server responses, error messages, and transfer the record the transfer of resource record information. So in the DNS message section, you have question, answer, authority, additional. So all of this is a part of the messaging sent as a query towards the DNS. So for DNS, they have a hierarchy. Okay, like for example, .com, .co, .my, okay, .eu, .au, okay, .net. Okay, we have a lot of level. So DNS, okay, they have at the back side is the DNS zone. Okay, DNS zone. And then you have the second level domain means that the level uh, at the front, okay, which means that which server based on the DNS. Okay, like for example, for email server for cisco.com, it got mail.cisco.com. For FTP, FTP cisco.com. Okay, the World Wide Web will be www.cisco.com. So all of them, okay, is a part of cisco.com, which is under a .com server somewhere else in the root level. Okay, in case you have for university, you have .edu. Okay, and then you have for business everything .com, the organization. Okay, even for the country .com.my. Okay, and people sell this. Okay, the access towards the back DNS. Some of them, one of the country in the world, which is called Tuvalu. Okay, they have .tv. Okay, which assigned to them. So they a lot of streaming website. Okay, video streaming website. Previously, they want to stream videos and everything. They ran the DNS under .tv. Okay, so they can get access. They can get their name more proper. Something .tv. Okay, so for IP addressing services, okay, you have this what we call NS lookup. So NS lookup is a computer operating system utility that allow a user to manually query the DNS server configured on the device to resolve a given host name. Means that you want to look into what kind of uh, server you are looking for, okay, and what is the IP address in case it is stored in your PC or not. Okay, the utility can also be used to troubleshoot name resolution issues and to verify the current status of the name server. When the NS lookup command is issued, the default DNS server configured for your host is displayed. The name of a host or domain can be entered at the NS lookup prompt. Okay, you can put it into the terminal with your Windows command NS lookup. You can find out what kind of IP address the server that you're looking for. Okay, so you can do anything you want with it. Okay, next we have DHCP. Okay, DHCP means that it is for IPv4 services that automates the assignment of IPv4 addresses, subnet masks, gateways, and other IPv4 networking parameters. This is commonly seen in Wi-Fi. So DHCP is considered dynamic addressing compared to static addressing means that any available address can be assigned to a PC connected to the network as it requests for DHCP. When a host connects to a network, the DHCP server is contacted and an address is requested. The DHCP server chooses an address from the configured range of addresses called a pool and assign it to the host. So the pool usually are limited. So in case there are more requests than available, some of the requests will not be successful. Okay, so many networks use both DHCP and static addressing. So the DHCP is used for general purpose hosts such as end user devices. Static addressing is used for network devices such as gateway routers, switches, servers, and also printers. Okay, for DHCP operation, okay, in case this is DHCP client and DHCP server, okay, so here DHCP configured device boots up or connects to the network. The client broadcasts a DHCP discover. They will send a DHCP discover to the server, and the server will send an offer. Once the DHCP receive the offer, he will request for that offer. And once he requests, okay, establish, okay, he put in DHCP acknowledge, and the establishment has been completed. Okay. So this one for NS lookup, you can even do it inside your own computer. Look for websites, mail servers, so that you can analyze by yourself. Okay, so next, I think this is about the end. File transfer, file sharing services. So we have file transfer protocol, which is what we call FTP. Okay, so the control connection is that the client open first connection to the server for control traffic. Client open second connection for data transfer. Okay, control traffic is for them to request and acknowledge any transfer or any missing when he send the data. Okay, and then data connection is where the data flows in. So usually we have several steps. Okay, here is step one. Okay, you have first connection to the server for control traffic using port 21 TCP. Clients establish the second connection to the server actual data transfer using port 20. Okay, this is for data. Then step 3, okay, the data transfer can happen in either direction. The client can pull data or push data to the server based on what the client intended. So only 3 steps for the FTP. And then we have SMB, server message block. Okay, this one is a client server request response file sharing protocol. Servers can make their own resources available to client on the network. 3 functions of SMB messages: start, authenticate, terminate session, control file and printer access, allow an application to send or receive messages to or from another device. Unlike the file sharing by FTP, clients establish a long-term connection to the server. After the connection is established, the user of the client can access the resource on the server as though the resource is local to the client host. Okay, so we have the module practice and quiz later on for this. Okay, I will activate all of them soon. Okay, so I will notify you once the activation is complete. So the quiz will be in NETACAD. Even previously you haven't completed the quiz for chapter 1, I will activate it again so that you can answer it again. So hopefully everything will be fine uh, for your assessment. So before we end, okay, I'll share the QR code for attendance. Now use your phone to get the QR code. Are you using your phone or using your friend's phone? Okay, done, done, finish,
Finish, sir.
Done.
done. Okay,
Thanks.
okay. So thank you for attending the class. Okay, for this week. We have 2 more modules left. Okay, and then most of the modules are available online. Okay, you can cover it by yourself. For the one that you have missed. Okay, so in case anything else, okay, do you have any question?
No, sir.
No, no.
No, sir.
Okay, so that's all for today. I'll see you guys next week, inshallah. Assalamualaikum.
Thank you, Doctor.
Thank you, sir.
Thank
Thank
you.
you,
Thank you,
sir.
sir.
Thank
Thank
you,
you,
Thank you,
Doctor.
doctor.
Thank you,
Thank you,
sir.
Doctor.
Thank you, sir.
Okay.
Thank you, sir.